Let's work on the contain duplicate algorithm. So let's look at a real life problem. Email blasting in MailChimp. So you just joined a marketing team at a startup. Your job is to send promotional emails to a list of users using MailChimp. Simple, right? But you notice something. Wait, why are some users getting two copies of the same emails? Oops, duplicate emails. This is bad for your brand and even worse for deliverability. If users keep getting spammed, Gmail or Outlook might start marking your domain as junk. So, have we accidentally added any email more than once? So, let's think of this as input, output, and constraint so that we can start practicing how an engineer thinks before we even touch the code. So, our input is a list of emails. Is either user IDs or it could also be order number. Anything that is unique. And the output for this problem is a simple yes or no. Do we have duplicates? Now, the constraint is that the solution needs to be fast because your email list may grow to millions and efficient memory use, especially if you are working with cloud compute where memory is equal money. Now, this forces you to think algorithmically, like an engineer. Can I spot the duplicates without checking every item against every other? And can I guarantee this solution is fast if our user base grows by 10? So, the first approach or the naive approach, as you're going to hear, is the brute force, which is a bad idea at scale. Let's see why. You could check every email against every other email like this. Is Martha's email same as Tim? No. The same as Amy's? No. Then you check Tim's. And is the same as Amy's? Yes or no? And you pretty much go through the email list. Now, this solution is O(n) square because if you had a million users, you'd be doing 1 trillion comparisons. And this is not good because in this day and age, no modern software does this. Not Gmail, not MailChimp, not you. So let's look at the brute force pseudocode. And before we look at this, let's define what pseudocode is if this is the first time you are encountering pseudocode. So pseudocode is what you write before you code. It's not code, it's not English, it's a mix of both. It's the stripped down, no syntax, human friendly way of explaining how a program will work without getting bogged down by the rules of any specific language like Python, JavaScript, or Java, or any other languages, right? So now that we know this, let's walk through the logic so that you really understand why this doesn't scale well. So first, we're going to build a process that checks a list of emails to see if any email shows up more than once. This is that function called contains duplicate. And then we start with the first email, then the second, then the third. So we go through all the emails one by one. Then in the inner for each, we go through every email. So every email that we check, we compare it to every other email that comes after it. And then we ask ourselves, did we find a match? And then if yes, we return true, we know that there are duplicates or there's a duplicate. If we check all the pairs and didn't find any matches, then there are no duplicates. So now that we have an idea of the brute force logic, just so that we can bring this home, let's go ahead and look at actual Python code. So I'm here in my code editor and I have a folder that I'm calling algorithms. And this one I'm going to call contains duplicates brute force.py. This is the file where we're going to implement that logic in Python. So first, I'm going to import the type list from Python, and then I am going to simply create a list of emails. As you can see here, we do have duplicates, but let's not worry about that right now. And let's go ahead and implement this in code so that you can match the logic with the code. Very important. Whenever you're working in algorithms, make sure that you have that inner dialogue, whether you're saying it out loud or you're just saying it in your mind. But having that inner dialogue will help you get this. I promise you that much. So let's get started. So the first thing is, again, we're going to build a process that checks a list of emails to see if any email shows up more than once. And this is a function called hasDuplicateEmail. So then we're going to start by checking the first email, then the second, then the third, and we are going to go through them one by one. So this is why we're using a for each loop in which we're going to go through the list of all the emails that we're getting as an input for our function. Perfect. So now, as we know, we want to compare the email to the email right next to it. So for this, we're going to iterate again, and we're going to get the next email, which is the email plus one, meaning is the next position in the list. A quick example to understand this is that here, when we start this loop, it's going to start with marta@fakeemail.com. But then when it jumps into this loop, it's going to do email plus one, which is index one, which is Tim. And at this point, we are setting the stage for us to compare Marta versus Tim, and so on and so forth. So the next thing we want to do is ask ourselves a question. Did we find a duplicate? And if we did, then we return true. There are duplicates in that list. But then lastly, if we didn't find any duplicates at all, then at that point, we simply return false. If you're following along, this is a great time for you to pause, implement, and make sure that you match the inner dialogue that I just went through. Now it's time for us to test. So what I'm going to do is make some room here, and I'm going to use Python's print function. And what I'm going to do here is I'm going to print whatever is returned from our hasDuplicateEmail function, and I'm going to give it this list of emails right here. So if I press play here, it's going to run the code, and it's going to say true. There are duplicates, and we can see that clearly in this short list. Now, if I eliminate all duplicates, bam, it says false. So this is your first code implementation. However, this is not really a good idea. Let's explore why. So let's answer the question, why this fails at scale. You must be asking yourself that, and also you must be asking yourself, if we know this won't work well from the get-go, why are we studying it? Just bear with me, and you will see that ultimately you need to learn to think in trade-offs. Also, it's important that you see naive ways of solving these problems in case you land a job where you have an existing code base where you might need to implement improvements. So knowing this will help you also identify where you can improve existing code. So imagine this. If your list of emails is 1 million, you're looking at doing almost 500 billion comparisons. Now imagine running this on a MailChimp campaign with millions of users. Your servers are going to cry and your emails are going to be late. Because in terms of time, the fact that we have to compare everything with everything puts us at O n square. And what happens is that this grows very fast as data increases. So it doesn't scale well. Now, in terms of space, it uses almost no extra memory because we get the parameter emails in the function. And we're going to see how this compares with the other solution. But for now, know that in terms of time, this would not scale well if you have millions of users. So now that we understand the brute force approach, let's go ahead and take a look at the optimal solution, which is to use a set or a hash set. So think like an engineer and think like the systems behind real products. Because Gmail ensures you don't get the same promotional email twice. Shopify only counts unique customers in analytics. Slack keeps track of who's already seen a message. So they use a data structure called a set, a tool built to track things only once. And you teach the computer this logic. Hey, computer, as you go through the list, keep a little notebook. Every time you see a new email, write it down. But if you ever see one that's already in the notebook, stop. That's a duplicate. So let's take a look at the pseudocode for this. So we're defining a function called hasDuplicateEmail. It takes one input, emails, which is a list of strings containing email addresses, and is going to return either true or false. Then I'm giving the computer a blank notebook called Seen. It can write down every email it sees in the list, but only once. And if it tries to write down something it already wrote, that means we've got a duplicate. Then we're going to go through the list of email one at a time. And this is our way of walking down the list. But then if it has seen the email before, it checks the notebook. And if it's already there, yep, found a duplicate. I'm done. I don't need to look at the rest. It contains duplicates. And if you haven't seen an email, you simply add it to seen. And because seen, which is the set, can only have unique values, then we know that if we stumble upon that email again, that's when we're going to get the alert, hey, you know what, we have duplicates. And lastly, if you look at every email and didn't find any duplicates, then we know everything is okay. So let's go ahead and write some code. So I have my file here, contains duplicates hashset.py. I'm gonna make some room, and we're going to start by importing the list type, and also I'm going to start by generating the list of emails. Perfect. So once again, let's go ahead and actually have our little dialogue. First, we are defining this function called hasDuplicateEmail. It takes one input, which is emails, which is a list of strings, and it will return either true or false, hence why we have this bool data type here. Good. So then we're going to create that notebook here, that blank notebook called Seen, and it can write down emails it sees, but only once. And this helps us make sure that there are no duplicates. So now let's go ahead and go through the list one by one. This is our way of walking down the list. Next, we are going to check if we have seen the email before, and if we have, this time around we're going to print the email that we found, and then we're going to return true. However, if we haven't seen the email before, that's where we add it to the seen set right here. Perfect. And then lastly, if we know there are no duplicates, we simply return false, like so. So if you're following along, let me make some room for you. If you're following along, that's a good time to pause and implement. Now that this is implemented, what we're going to do is simply test it again. And if there are duplicates, we should get true. And perfect. True. And now we're going to just get no duplicates here just to test the logic. And there are no duplicates here, so it's false. Perfect. So let's take a look at why this is better. So in this specific use case, let's discuss why this scales better. So if you have a list of emails of 1 million, then you're only performing 1 million operations, not 500 billion. Also, imagine running this on a MailChimp campaign with millions of users. Your app stays fast, your emails go out instantly, and your servers are still smiling. So instead of comparing every email to every other one, you use a hash set, which is a lightning fast tool for tracking what you already seen. And this scales because our time complexity is not O(n) squared. This time is O of n. One pass through the list, no nested loops, more emails, still just one pass. Now, in terms of space, we do use more memory because we are storing every email in a set, up to n meaning the amount of emails in the list, and n meaning is going to be as big as the list. However, we have to think about the fact that the brute force had a lower cost in terms of space, but a much higher cost in terms of time, as you can see here. So, what does this mean? Well, brute force is cheap in memory, but as you can see, it's very expensive in time. However, the Hachette solution is very cheap in time, but has extra cost in memory. In the real world, time almost always matters more because users don't want to wait 10 seconds for email to duplication, and servers usually can handle a few extra megabytes of memory. So apps like Gmail, Slack, MailChimp, and Shopify, they all prefer time over space when the user scale is high. Now let's think of the engineering mindset of this algorithm. Smart engineers don't just ask, does it work? They ask, will it still work when everyone shows up? Hachette is your answer to that question. It's how real systems deduplicate at scale, fast, reliably, and predictably.